So we are to determine the current through the 5 ohm resistor, that is this, in the circuit below, using Thevenin's theorem. So we know that in Thevenin the first step is to remove the resistor through which you are finding the current. So in this case this, and we will find our VTH applying KVL, right? So our new circuit will look like this. You will remove it like this. This is our 2 ohm here, down here. This is our 10. So here's our 2 ohm. Here's our 10 volts. This is a positive, negative. This is also 2. We have 3 here. We have 2 ohm. We have 7 ohm here. Then we find our VTH. Let's move this direction. So before we can find VTH, we have to use KVL to find it. So let's say this voltage source will produce a current, let's say I, and this I is the same current that will flow through this 3 ohm. Why? Because here is open and this current won't even go here, so it will just flow through the 2 ohm and the 3 ohm like this. Let's say this voltage source also produce a current, say I1. It is the same current that will flow through this 2 ohm and this 2 ohm, because here is open, so this current won't go to this side. So let's see what will happen. We can write an equation and find and write an equation and also find I1, and we can write an equation involving VTH so that we can find the value of VTH. That is the most important thing. So we can say that V, or 7 volts, is equal to 2 plus 3 I when we take this loop. So we can say that 7 is equal to 5 I. We can say that I is equal to 7 out of 5 amp. In taking this loop, let's go this way counterclockwise. We can say that minus 10 should be equal to 2I1 plus 2I1, because this is 2 and the current flowing through this one is I1 and this one to I1. So you can say that minus 10 is equal to 4I1. So I1 will be equal to minus 10 on 4 amps. So what we need right now is to find our VTH. Taking a look at this loop, we will treat this VTH as a voltage source. So we can say that VTH will be equal to 3I minus 2I1. Why? Because we are going this direction, okay, and this I is in the same direction of ours, and this is moving in the negative direction of ours. That is why we have minus 2I1 here. So we can find VTH since we know I and I1. So it will be 3I. We had 7 on 5, and I1 we had minus 10 on 4. So VTH will be equal to 7 on 5 minus 2 bracket minus 10 on 4. So our VTH will be 46 out of 5 volts. So in Thevenin, after finding your VTH, the next step is to find your RTH, and in RTH we deactivate all the voltage sources. We short them because these are voltage sources, and we look through this terminal and find RTH. Okay, so this is how the circuit will look like after we short them. So here is our 2 ohm, 2 ohm, 2 ohm, 3 ohm, and another 2 ohm over here. And this is our terminal. When we look through this terminal, we can see that, so the RTH, we can see that this and this are in parallel. this and this are also in parallel, and they are in series with this. So let's see. 2 parallel 3, and this is also 2 plus 2 parallel 2 over here, and they are all in series with these 2. So we can say that RTH will be equal to, this should give us 6 on 5 plus 2 parallel 2 is 1 plus 2. So our RTH should be equal to 21 on 5. So the equivalent circuit now should look like this. This is our VTH, RTH, and we will bring back the resistor that we took out, that is the 5 ohm resistor, that is the 5 ohm. This is our RTH, that is 21 on 5 ohm, and this is our VTH, that is 46 on 5 volt. So finding current here should be very easy. That is VTH RTH plus RTH R, because this and this are in series. So the VTH is 46 on 5, all out of the RTH is 21 on 5, plus the R, this is the R we took out, so plus 5. So I should be 46 on 5, just 21 on 5 plus 5. That should give us 1 ampere. So you can conclude that the current flowing through this 5 ohm resistor is 1 ampere. Okay, so in this question we have to determine the current through the 0.1 ohm resistor, in this case this, in the circuit below, using Thevenin, right? So we know what we have to do when we are using Thevenin. We will take out the resistor in which we are trying to find the current through. So in this case, the 0.1 ohm resistor. So this will be our new circuit. We take it out and we will find our VTH. So like this. This will be 0.4 ohm. This will be 2 amperes here, and we will find our VTH. Let's take this direction. It can be any direction. It depends on you. So this is 5 amperes here. Good. So let's see. This 5 amperes will flow like this, and will flow back through the 0.5 ohm and come back like this. It won't go here because there's an open circuit here. So this 2 will also flow through the 0.4 ohm and come back like this. It won't go to this side because here is open. So that means that 0.4 amperes, this is 2 amperes is flowing through this 0.4 ohm resistor, and this 5 amperes is flowing through the 0.5 ohm resistor. So we can write an equation involving VTH, and we will find our VTH, which is very simple. Going this direction using KVL, VTH should be equal to 0.5 ohm times the current, that is 5 amperes, minus, because this current is opposing our direction, so it will be 0.4 times 2. So our VTH should be equal to 17 out of 10 volts, which is the same as 1.7 volt. Right, so getting our VTH, our next action is to find our RTH. So RTH, we deactivate all sources. When they are voltage sources, we short them, and when they are current sources, we open circuit them. And in this case, we have current sources, so we will open circuit them, and this is what will happen. This will be open, and we will have 0.5 ohm here. We have our VTH here. This will be 0.4 ohm, and we will open. You see there is 2 amperes here, which is a current source, so we open it here. In here is 5 amperes, so we open because this is a current source. If this was to be a voltage source, we would have short this place like this, but in this case it's a current source, so we open circuit them, and we will find our RTH looking into this terminal like this. So from this, our RTH should be equal to what? This and this will be in series because the current flowing through, let's say there's a voltage source here providing a current. The current that will flow through this 0.5 ohm will be the same current to flow through this 0.4 ohm. So it will be 0.5 ohm plus 0.4 ohm, which is 0.9 ohm. Yes. So in Thevenin, if you have your VTH and RTH, you are good to go, because the equivalent circuit for Thevenin is like this. We have our VTH over here, which is 1.7 volts, and our RTH, which is 0.9 ohm, and we will bring back the resistor that we took out, that is 0.1 ohm. So finding the current through the 0.1 ohm will be VTH out of RTH plus the resistor we took out. So it will be 1.7 volt out of 0.9 plus 0.1 ohm, which will give us a certain current, which is 1.7 amperes. Okay, so we are to calculate using Thevenin's theorem the current through the KINEMARC branch. So looking at the diagram, you can see that this is a KINEMARC branch. So what they mean is that, or what it means is that we are finding the current through this 5 ohm resistor. So as always in Thevenin, we remove the let me say the resistor through which we have to find the current, or the branch through which we have to find the current. So in this case, we will remove the 5 ohm. So this is how it will look like. It will look like this. This will be our 3 ohm here, our 4.5 ohm, 4.5 ohm here, 3 ohm, 3 ohm. This is 24 volts. This is 6, and we removed. So we will find our VTH here, where we removed the resistor. We can only find that using or applying KVL, Kirchhoff's voltage law. So let's say this 24 volts source produces a current through this branch. When it gets to this node, there will be a split. Since here there's a node here, there will be a split here. So let's say I2 flows through this direction and I1 flows through this direction. So let's see, we can take loops and find the value of I1 and I2. So let's see, we can take this loop, and write an equation for I1. So let's see, I1 will flow through this 3 ohm, through this 4.5 ohm, and through this and 4.5 ohm like this. So taking this loop, okay, so it will be 24 will be equal to 3 plus 4.5 plus another 4.5 all times I1, because I1 will flow through 3, 4.5, and this 4.5 again. So it will be 24, which will be equal to this should give us 12 I1, and I1 will be 24 out of 12, which is 2 amps. Okay, we can also take this loop here and write an equation like this. So it will be 24, that's this voltage source, and we have 3I2 plus 6I2 plus this 3I2. So it will be 24, which should be equal to 3I2 plus 9I2, which is 12I2 here, 24. So I2 should be equal to 24 out of 12 again here. So we will have 2 amperes for I2, this current. Right, so our main aim is to find this VTH. So we can find VTH like this. So VTH should be equal to minus 3I2. We are going this direction. I'm picking this loop like this. So VTH is in this direction, and this I2 is opposite our direction. That is why I have minus 3I2 here, but I1 is in my direction. So I will say that plus 3I1 plus 4.5 I1, which is VTH, should be equal to minus 3I2 plus 7.5, adding 3 and 4.5 I1. But we know the value of I2 and I1, so we can substitute. So it will be minus 3. We had I2 to be 2, 7.5, and I1 to be 2. So VTH will be equal to 9 volts here. Right, so our next step is to find RTH. In finding RTH, we activate all sources. When they are voltage source, we short them, and when they are current source, we open. But in this case, it is a voltage source, so we will short it. But we can see that this and this are in parallel, in series, and this are in series, and they are in parallel. So let me draw. This is how it will look like. It will look like this. This will be the terminal. This will be our RTH. I'm saying that we have this and this to be in series, so it will be 7.5 ohm here, and in parallel with this 4.5, so like this. And when we come here, we have this and this to be in series, that is 9 ohm, and in parallel with the 3 ohm like this. And they are, this and this are in parallel, this and this are in parallel, and they are all in series. So our our total will be equal to 7.5 parallel 4.5 in series with the parallel combination of 9 and 3 here. So it will be 9 parallel 3, and after calculating you should get 5.0625. And now that we know our RTH and VTH, we can find our VTH. No, now we know our VTH and our RTH. We can find the current through the branch, that is this. So it will look like this. This should be our VTH, this should be our RTH, and this will be the branch that we are supposed to find the current through. In this case, the 5 ohm. But we had our RTH to be 5.0625 ohm, and our VTH to be 9 volts. So the I will be VTH out of RTH plus the R, this R that we removed. Okay, so it will be equal to 9 volts out of 5.0625 plus 5, which should be 9 out of 5.0625 plus 5, which is 144 out of 161 ampere. And in decimals, I will be equal to say 0.894 amperes. I mean the current IL in the network using Thevenin. So this is the IL here. So it means we are trying to find the current through this 10 ohm resistor. And we know that in Thevenin we need to find our RTH and our VTH, and then we can find the current IL. So I'll start by finding my RTH, and this is how we find RTH. When you want to find the RTH, you deactivate all sources. And this time we have 2 sources here, so we will deactivate all of them, and since they are voltage sources, we will short circuit that place, and we will remove the resistor in which we are finding the current through. So in this case, the 10 ohm. So this is how the circuit will look like when finding the RTH. It will look like this. This is our 6 ohm, this is our 4 ohm, this is our terminals. So you see that we've removed the 10 ohm resistor from this side, and we've short circuited this side. That means we've deactivated the 12 volts and the 10 volts. So looking through the terminals like this, we can find RTH. We can see that 4 and 6 are in parallel, so the RTH will be equal to 6 parallel 4, which is the same as 6 multiplying 4, 6 plus 4, which is equal to 12 out of 5 ohms. So after finding this, we will find our VTH, and this is how we find the VTH. We have our voltage source here. We have this one also here, and we have this. So we can find our VTH from this terminal. We have the 12 volts here, and you have a 10 volts here. We have 4 ohm and 6 ohm. These are the terminals. So we see that we can only find VTH using KVL, that is Kirchhoff's voltage law. When this voltage produces a current, for example, let's say I, this I will flow through this loop. It won't go through this side because here is open circuit. So this I is the same current that will flow through this loop like that. So we can write an equation involving VTH, and as well as an equation that will help us to find the I, which will help us find the VTH. So writing an equation for the I, we have, using KVL, we have going this direction, we have 10 minus 12 should be equal to 4I plus 6I. We will have minus 2 here, and 10I, and our I will be equal to we can write an equation for VTH going this direction. So VTH, because we are treating this as a voltage source, so it will be VTH minus 12 should be equal to this. The voltage drop in this loop is just this one, so 6I. So VTH, that is our main focus, will be 6I plus 12. So VTH will be 6 times the I. We had minus 2 on 10 plus this 12. So VTH should give us 10.8 volts. Yeah, and the equivalent circuit for VTH, the equivalent circuit for Thevenin is this. You have your VTH in VTH like this, RTH, and you bring the resistor in which you find the current through. So we have our VTH, which is 10.8 like this. We know our RTH, which is 12.5 ohms, and the resistor that we are finding the current through is 10 ohm. So we'll bring the 10 ohm here. So from this diagram we can find the current through the 10 ohm, which is very simple. In this case, it will be I should be equal to your VTH all over the RTH plus the R. We have VTH to be 10.8 and the RTH to be 12 on 5, and the R in this case the 10 ohm, and we should have 0.87 amperes. So in this question it tells us to determine the Thevenin's equivalent across the terminal A and B. We can see this is A and B, right? So we can make this this circuit very easy. This is just a wire, so we can turn it like this, turn this like this, and it will make it look like this. Very simple. Just follow and you will understand. It will come look like this. This is your 1 ohm. This is your 10 ohm. Like this. 9 ohm, 1 ohm, 10 volts, 12, 8, and 20 volts here. So we turn this side like this to make it look like this. If you can see, we turn this upside down. So can you see? I'm sure. So let's continue. So this will be the A and B. So this is our VTH. This is the point. Let's say A, B. And we have find the current the Thevenin's equivalent like this. So before we can find Thevenin's equivalent, we know that we have to apply KVL to find the the VTH. So let's say a current I will flow through this loop, and it won't go here because here is open. So this I will be the same I flowing through this, and it will be the same I flowing through this 8 ohm. Similarly, if this voltage source produce let's say current I1, it will flow through that 9 ohm and that 1 ohm as well. So we can write an equation for this loop and write an equation for this loop, and after that we will write an equation involving VTH and find the value of the VTH, because we are just to find the equivalent. If you remember, the equivalent circuit across the terminal A and B, right? So taking this loop, we can say that 20 should be equal to 8I. This is the 8I plus this 12I. Should be 20 should be equal to 20I. So I will be what? 20 out of 20 which is 1 ampere. So taking this loop in this way, counterclockwise, we can say that 10 volts should be equal to 9I1 plus 1I1. This 10 should be equal to 10I1. So I1 here will be equal to 10 out of 10, which is 1 amp. So we can see it is very simple. But our aim is to find the VTH. So the VTH, we can take a loop like this loop. We can take this loop and find our VTH. So our VTH, that's the only voltage source here because we are treating the VTH as a source. So VTH should be equal to 12I, because this is in the direction of our, this I is in our direction, so it will be positive. This is in a negative direction, so we say that it will be minus I1, but we know the value of I1 and we know the value of I, so just substitution. So it will be 12I, I is 1 minus 1, so it should give us 11 volts for VTH. Very simple. And in Thevenin, after finding your VTH, you find your RTH. And how do we find RTH? We deactivate all sources. So in this case, we have 20 volts and 10 volts, so we will deactivate them. And after that, we look through the terminal, this terminal, and find the RTH. So it will look like this. It will look like this. We have our 1 ohm here, 9 ohm, then we deactivate. Since they are voltage sources, we short them. So what can we say when we look through this loop? What can we say, or what's the relationship between these resistors? We can see that this and this are in parallel. So we can say 8 is in parallel with the 12, and this are also in parallel. So 9 parallel 1, and they are all in series. So we should have 4.8 for this, 4.8, and 0.9 for this. So our RTH should be equal to 5.7 ohm. So the equivalent circuit will look like this. You have VTH over here, RTH, and the terminal. This is the terminal AB, if you remember from here. You remember this is the AB, or even from here you can see the AB here. So this will be our RTH and this will be our VTH. We know the value of VTH already, which is 11 volts, and the RTH, which is 5.7 ohms. So 5.7 ohm. So this will be the equivalent, the Thevenin equivalent across the terminal AB for this particular question.